In this lesson, we're going to learn how to write a linear equation in slope-intercept form from a word problem. Then we're going to be able to take that linear equation, which is a linear model, and answer further questions. When creating a linear equation, just like we've learned algebraically and graphically, you need to know the slope and the y-intercept. For our word problems, we'll consider the slope a constant rate of change. The y-intercept, we're going to call it our starting point. And then we're going to put those two values, m and b, the constant rate of change and your starting point, into the equation y equals mx plus b. Let's take a look at example number 1. Mr. Einstein sells math worksheets on Teachers Pay Teachers, TPT. He says TPT, or he pays TPT, an annual fee of $60. So every year he has to pay $60. However, he receives $3 per item that he sells to other educators. Create a linear equation in slope-intercept form that models how much money Mr. Einstein makes in a year. Then we're going to answer the question, how much money would he make if he sells 700 worksheets or items in a year, and how many worksheets he must sell to earn $2,640 in a year. So let's take a look at the first part of the word problem. He has to pay $60 each year to TPT, so he's going to be starting out in the hole, negative. However, every time he sells an item, he earns $3. And it says to write this in slope-intercept form to model how much money he makes. So our constant rate of change is the $3. So M is 3, and it's $3 per item. However, he's starting in the negative, in the red, they say. So he has to pay $60 to TPT up front. So the starting point, or the initial value of money, is negative 60. Now we can write the equation, or also called the linear model, y equals my $3, and my x value, it says $3 per item. $3 per item, so 3 times x minus the 60. Now, once we get the equation established, we have established what m represents, what b. Now we need to know and ask ourselves, what does the y represent and the x? Well, my x value, just like it said in the word problem, is per item. So x is item, or we could say the number of each worksheet. So as the worksheets increase, the sale of worksheets increase, our sales, or the money we make, is going to increase, and that tells us the y. Y is usually a total of something, of whatever your word problem is talking about. And we were writing this to see how much money he makes. So y is going to be the total earnings. Okay, now let's take our model, y equals 3x minus 60, and let's apply it. How much money, and remember y is total money, so we're looking for y. How much money would he make if he sells 700 worksheets in a year? So 700 worksheets, we know worksheets is our x value, so we're just going to simply plug in 700 in for x, and then work out our problem. So 3 times 700 is going to be 2,100, or 2,100, minus the 60, because he has to pay that to TPT. So when we subtract this out, we're going to get 2,040. So this is how much money he's going to make in a year if he sells 700 items. Now let's take a look at how many worksheets must he sell. So we're looking for x. How many worksheets? We know x represents worksheets. So how many worksheets must he sell to earn a total of 2,640? So this time they give us the total earnings, and we must find the x value. So we're going to plug in 2,640 equals 3 times some number of worksheets minus 60. So we're just going to solve for x. So we need to undo minus 60. So we're going to add 60. And this gives us That's going to be 10. So 2,700 or 2,700 equals 3x. We're going to divide by 3. And x is going to equal, so 3 goes into 27. So it's going to be 900 worksheets. Okay, so be able to make sure that you know what your x represents and your y. So when you're given future questions of the model you've created, you know where to plug in your number, either for the x value or the y value, your input or output. Example 2, the Durham Walls had a pool put in for their grandkids. The pool held 240 gallons of water. However, the pool began leaking, so it's leaking, it's going down 20 gallons per hour. How many gallons of water will be in the pool in 7 hours, and how many hours will it take for the pool to completely be drained? Okay, let's represent the slope. So my slope is 20 gallons, and it's going down per hour. So if it's leaking, we know that's going to be a negative. It's going down 20 each hour. How much did we start with, though, of water? 240. Now, I want to make sure you understand, if this 20 was not in gallons, like our initial value, you would need to make sure that these units always match. So you may come across some word problems where you're given gallons and maybe quarts, and you would have to change one or the other so that the units match. So always make sure your units match. Now, it didn't say it in the instructions, but it should have asked you to write a linear model, excuse me, to represent the total amount of water. So let's do that. So y equals, it's going down my slope, my constant rate of change is negative 20 times x plus the 240 that it starts out with. My x value, it comes from the word problem, guys, so it's 20 gallons per, or each is always a key word, so 20 gallons per hour. So x is hours. For every hour, the pool is leaking 20 gallons. It's losing 20 gallons of water. And again, your output is usually going to be a total of something. So this is going to be the total amount of water or gallons of water that is in the pool. Now let's apply. How many gallons of water, so how many gallons of water will be in the pool in 7 hours? So you can see that we're looking for the y value, how many gallons of water. We've been giving the x value because x represents hours. So we're just going to plug in y, the total amount of water in the pool, is going to be negative 20. And we're plugging in for 7 hours for x plus the 240 that it begins with. So when I multiply negative 20 times 7, and then I combine these, so that's going to give us 100. So 100 gallons is what will be left in the pool in 7 hours. Says how many hours will it take for the pool to be completely drained? So we're looking for x. How many hours? X is hours. So for it to be completely drained means that we have 0 gallons of water in the pool. So 0 is my y value. We're looking for x. We're looking for how many hours it's going to take to be completely drained. So we're just going to solve for x. We need to subtract out the 240. Divide each side by negative 20 to isolate our x value. And we get a positive answer here. And it's going to be 12 hours so that there's no water in the pool. Now you guys try these.